What if I told you that inside a manufacturing plant in Union City, California, tucked quietly in the shadow of Silicon Valley, a precision machined steel rotor is spinning at thousands of revolutions per minute inside a sealed vacuum chamber, holding enough energy to keep your home running through a blackout? And this machine contains no lithium, no cobalt, no flammable chemistry, and no scheduled expiration. This is not a lab experiment. This is not a university grant project. This is Amber Kinetics, a company founded in 2009 that has quietly logged over 1.6 million cumulative operating hours across deployments on multiple continents, discharged more than 2 gigawatt hours of stored energy into real grids, and just signed a historic partnership with Kawasaki Heavy Industries, one of Japan's most formidable industrial institutions, to scale this technology across the United States, Australia, Southeast Asia, and eventually everywhere else. The rotors are already turning. The contracts are already signed. Real grids are already running on this right now. For a decade, the energy storage conversation has been dominated by lithium-ion batteries. They are in your phone, your laptop, your electric car, and increasingly strapped to utility substations and the sides of homes. And for a decade, the industry has been selling you a vision of the clean energy future while quietly looking past a fundamental problem buried deep inside every one of those cells. Lithium degrades. Each charge and discharge cycle is a small act of molecular destruction playing out inside the pack. After 3,000 to 8,000 cycles, the battery that was supposed to store 10 kilowatt hours can barely manage 6. It is vulnerable to temperature extremes. It can ignite. It depends on cobalt extracted from regions that make ethical supply chains nearly impossible to guarantee. And most critically of all, it cannot respond instantly to the brutal, unpredictable demands of a modern electrical grid. When a wind farm suddenly goes dark, when a cloud passes over a solar field, when a hospital's emergency systems need full power in a matter of milliseconds, a lithium battery hesitates. It consults its battery management system. It brings itself up to temperature. And in that gap, that thin, invisible gap measured in fractions of a second, grid frequency destabilizes, equipment trips offline, and a cascading failure begins to build. This is the exact problem that Amber Kinetics was designed to eliminate. And the solution is so physically clean, so rooted in first principles, that it almost feels obvious in hindsight. Here is how it works, because the physics is where the ore lives. Imagine a massive steel rotor, 98% steel by weight, machined to extraordinary precision, perfectly balanced, enclosed inside a vacuum-sealed housing. When surplus electricity is available, whether from a solar installation at midday, a wind turbine in the early morning hours, or cheap off-peak grid power, a motor drives this rotor to high rotational speed. The electricity is not stored in a chemical bond or an electrolyte or a polymer. It is stored as pure kinetic energy, as motion itself, locked into the physics of angular momentum. When the grid needs that energy returned, the motor inverts. It becomes a generator. The rotor decelerates almost imperceptibly, converting stored motion back into clean AC electricity. The response is near instantaneous, governed not by electrochemistry, but by the laws of physics that have described spinning objects since the beginning of the universe. And here is the part that changes the entire calculus. There is no degradation, none whatsoever, because no chemical reaction is taking place. There is nothing eroding at the molecular level. The steel does not break down. The storage medium is not consumed by the act of cycling. You can charge and discharge this system every day for 30 years, and it delivers identical performance on cycle 100,000 as it did on cycle 1. That is not a line from a marketing deck. That is a consequence of physics. But Amber Kinetics did not simply build a better flywheel. They built something the entire flywheel industry had been chasing and failing to achieve for decades. They built a flywheel that discharges for 4 hours. This is not a minor footnote. Traditional flywheels discharge in seconds, minutes at best. They are bridge devices useful for covering the window while a diesel generator comes online, but completely inadequate as primary energy storage because they run out too fast. Amber Kinetics solved this problem. Their M32 system, 8 kilowatts of continuous output, 32 kilowatt hours of stored energy, 4 full hours of sustained discharge, is the first commercialized long-duration flywheel ever brought to market. The industry had been attempting and failing for decades. Amber Kinetics is the only company on earth that has done it. Not in a controlled laboratory environment, in manufactured, deployed, grid-connected units operating right now across the United States, the Philippines, Hawaii, Germany, and beyond. This is not iteration. This is an entirely new category that did not previously exist. A 4-hour discharge flywheel performs the identical function as a 4-hour lithium battery bank. Load shifting, peak shaving, renewable firming, but without degradation, without fire risk, without cobalt, and without the replacement cycle every 10 to 15 years that quietly doubles or triples the true lifetime cost of chemical storage. A lithium installation has a built-in expiration date factored into its economics from day one. An Amber Kinetics installation carries a 30-year design life with no capacity loss and no scheduled replacement. The customers who figured this out are not early adopters chasing novelty. Pacific Gas and Electric selected Amber Kinetics for its 20-megawatt Fresno project in California's first energy storage solicitation. Hawaiian Electric is running a grid-connected demonstration on Oahu. Military installations across the United States, where reliability is measured not in dollars but in consequences, are running on this technology. Island communities across the Philippines, where the Department of Energy has officially recognized the technology as a pillar of the country's microgrid strategy. And then there is Kawasaki, one of Japan's most technically demanding heavy industrial firms, a company that manufactures aerospace structures, naval vessels, and precision railway systems to tolerances measured in microns, sights down to evaluate energy storage options and selects flywheels over chemical batteries. That is not a branding decision. That is an engineering verdict. Kawasaki selected Amber Kinetics for unlimited cycling capability, zero fire risk, freedom from hazardous materials, and a verified track record of more than 1.6 million operating hours. Their combined platform pairs Kawasaki's virtual synchronous generator technology with Amber Kinetics flywheel storage, making solar and wind generation behave like traditional spinning generators, complete with real physical inertia that keeps grid frequency anchored and stable. This addresses the deepest structural vulnerability of the energy transition, the fragility that emerges when spinning generators are displaced by power electronics that produce electricity without rotational mass. The Iberian Peninsula blackout, the largest grid failure in recent European history, is precisely the kind of cascading frequency collapse this system is engineered to prevent. Kawasaki and Amber Kinetics announced their partnership in the direct aftermath of that event. Grid operators across the world were asking the same question. How do we make sure this never happens to us? The answer is spinning mass. It has always been spinning mass. Now bring this close, because the commercial and distributed opportunity is where this becomes personal. A 4-hour flywheel installed at a commercial building or industrial facility transforms the economics of energy independence in ways that chemical storage simply cannot replicate across any realistic time horizon. The flywheel absorbs daily cycling without penalty. The same deep daily charge and discharge routine that slowly destroys lithium cells causes zero performance loss here. It functions across wide temperature ranges without supplemental cooling infrastructure. It requires no specialized end-of-life disposal. It is 98% steel and fully recyclable, and it presents no fire hazard to the structure it serves. For island communities, Hawaii, the Philippines, Pacific Island nations, where energy security is not a convenience but a survival question, and where grid reinforcement cannot be achieved by laying new transmission lines across thousands of miles of open ocean, the flywheel's ability to firm renewable generation without ever degrading is not just attractive, it is the answer. The manufacturing footprint is scaling to meet the demand. 2 purpose-built facilities in Philippine Special Economic Zones are producing at a combined rate of 4,000 units annually, with expansion plans targeting U.S. manufacturing sites that will bring production capacity closer to the world's largest energy markets. The American headquarters in Union City continues to lead next-generation engineering across mechanical, electronic, software, and systems integration, all under one roof, preserving the vertical integration that guarantees quality from initial design through final deployment. This is also a story about geopolitics. The United States electrical grid is aging and increasingly unable to absorb the simultaneous surge from AI data centers, electric vehicles, and electrified industrial processes. The traditional response, build larger plants, extend transmission infrastructure, wait a decade for permits, is not a solution for a crisis that is already happening. Distributed energy storage positioned at the edge of the grid, where the actual load lives, is the answer that does not require a decade of permitting. It requires manufacturing, installation, and a steel rotor spinning in a vacuum. Amber Kinetics uses no rare earth minerals, no cobalt, steel, one of the most abundant, most recyclable, most supply chain resilient materials on the planet. Its core components are manufactured within geopolitically stable networks. In an era when lithium supply chains run through Central Africa and cobalt procurement maps through chronic political instability. Building grid-scale energy storage out of steel is not just a technical preference, it is a strategic imperative. The comparison that matters is not flywheel against lithium in a single installation on a single day. It is flywheel against lithium across 30 years, across 100,000 cycles, across a grid that is demanding faster and faster response to increasingly erratic swings in supply and demand. Measured on that timeline, at that scale, the steel rotor wins. More than 2 gigawatt hours of energy have already been discharged through Amber Kinetics flywheels into real grids serving real load. Those hours accumulated without a single fire, without a hazardous materials event, without a single capacity degradation report, without a replacement. The units installed earliest are delivering today exactly what they delivered on their first day of operation. This is what 30 years without degradation looks like in practice, not as a specification printed on a datasheet, as documented operational reality measured in runtime hours logged in the field and verified by utilities and grid operators who have no patience for storytelling and every incentive to report the truth. We have been told the clean energy transition requires compromise, that renewable energy means accepting intermittency, that storage means accepting degradation, that grid resilience means accepting cost and complexity. The grid we have was engineered for the energy mix of the past 50 years. It was not built for what is coming. Amber Kinetics is not asking the grid to renegotiate its physics. It is supplying exactly the physics the new grid demands. The steel rotor is spinning, the vacuum is holding, the energy is waiting, and unlike a battery, it will still be waiting at full capacity, without hesitation, without degradation, 30 years from now.